Hi, welcome back to Unit 1 here in AP Physics C Mechanics. We're still working on kinematics, all right? And in this video is going to be a little bit of review of stuff you did last year or the stuff from the Physics 1 course. It's because we're going to assume that the acceleration is constant, okay? So those constant acceleration kinematics equations, or what we call in my classroom cake, they're going to, right, we make this big assumption that the acceleration is constant. Right? All the way up until this point, a lot of our stuff has just been, hey, the acceleration could be non-uniform, it could be constant, and that comes from what the position function is going to give us, right? So the first two equations that we do focus on here in cake are the equations of two of the three graphs in kinematics, right? So the position versus time graph and the velocity versus time graph. So for position versus time graph, right? If we have an acceleration, we know that that is a quadratic equation, okay? And if we have an acceleration, we know that our velocity versus time graph is a line, right? It's a slope line. And then the third cake equation, or the third cake, right? I always say cake equations, but the E in cake means equation. Is very important because it's the one with no time. So V squared equals VO squared plus 2A delta x, right? And so I do want to point out in these equations is that there's five factors, right? There's delta x, there's initial velocity, there's final velocity, there's acceleration, and there's time, right? And something to note is all the equations there have four of the five factors. For example, if we look at the quadratic, that combination of x equals xo, that's delta x. Well, there's our VO, there's A, and then you see T pops up twice, okay? The thing that this one is missing, right, is our final velocity. Look at the next equation, right? So final velocity, initial velocity, acceleration, and time. So this equation is missing our delta x combo. And if we go down to the last one, right, delta x, A, V, and VO. So that one is missing time. So sometimes when you do these equations, kind of like a matching right now on the screen, but sometimes when you do these equations, sometimes it's best to find the missing piece. That'll lead you to the right equation. And again, this goes back to our stack, right? X, V, A. And we know that, so parabolic, right? But we know that V is the derivative of x, so it probably becomes a line. But we also know that A is the derivative of position or velocity, but it's also the second derivative of position, and we know that's constant. Okay, so there's our stack. Okay, now let's look at an example. So here we have a spaceship leaving Earth's orbit and on its way to the moon. It accelerates at 20 meters per second square for 2 minutes, covers 1,000 kilometers. What are the initial and final velocities of the spaceship? So if we write down what we know we have an acceleration of 20 meters per second squared, positive. We know we have a time of 2 minutes, but we need to put that in seconds, so 120 seconds. And we know we have a delta x of 1,000 kilometers, or 1,000 times 10 to the 3 meters. Okay, and we're looking for V and V0. Okay, so if I want to find V0, here are my factors, right? So there are my four. The missing one would be our velocity, or final velocity. So there's one equation that doesn't have final velocity in it, and it's x equals xo plus VOT plus 1/2 AT squared. Okay, again, that x equals xo, this combo right here, is delta x. And so we're going to say 1,000 times 10. Oh, let's solve it first for what we're looking for. So we would have, it'd be delta x equals VOT plus 1/2 AT squared. And so we're going to subtract over the 1/2 AT squared and then divide the whole thing by t. So our initial velocity is going to be given by delta x minus 1/2 AT squared divided by t. Okay, and now we can plug in our numbers. So V0 equals 1,000 times 10 to the 3 minus 1/2 times 20 times 120 squared divided by 120. I don't have my filled out copy of the notes. I have to do this in the calculator real quick. So we have 1,000. So 1,000 times 10 to the 3 times a minus 0.5 times 20 times 120 squared. And that's 856,000 divided by 120. So our initial velocity is 7,133 meters per second. Okay. Now we have that factor, and so if I want to make it easy on myself, I look at these three or these four, leave the delta x out of it, and get V equals V0 plus AT. And so I end up with V equals 7133 plus 20 times 120. So make your life a little bit easier by choosing the right equations to make it easier. And so we find that the final velocity is 9,533 meters per second. So again, this video was really a review of last year, right? Because in Physics 1, or in a Physics 1 course, I shouldn't say last year, because making an assumption you've taken Physics 1. But this video is a review of Physics 1 in the sense that we look at constant acceleration, right? Now, Physics C, that's not our focus, right? Our focus is a lot of times is that non-uniform acceleration, okay? So look forward to doing